In Lesson 3.4, the target states, I can solve equations containing decimals. So we're solving equations similar to those we solved in Chapter 2, only this time, in the equations there are decimals. So we're going to apply some similar strategies to those we've already learned. So for example, s minus 2 equals 5 is an equation we learned how to solve. S minus 2 equals 5. Minus 2, the opposite of subtracting 2 is adding 2. So I can see the answer is 7, because 7 minus 2 equals 5. But the strategy that I need to apply is going to be necessary when I'm dealing with decimals in my equations. So the opposite of subtracting 2 is adding 2. So if I add 2 to both sides, minus 2 plus 2 cancels out, becomes a 0 pair. I'm left with s equals 5 plus 2, so s equals 7. And if I want to check my answer, I'll plug it back into the equation. 7 minus 2 equals 5. 5 equals 5. So the solution checks out. Now when we're dealing with decimals in equations, it's even more important that you can remember the strategies for isolating the variable or solving for the variable. So s minus 3.8 equals 7.2. The opposite of minus 3.8 is plus 3.8. But I have to add 3.8 to both sides. So what would I be left with? So if I find the sum of my equation now, minus 3.8 and plus 3.8 equals 0. So I'm left with s equals 7.2 plus 3.8. So 7.2 and 3.8, if I line up the decimals to add, 8 plus 2 is 10, carry the 1. 3 plus 7 is 10, plus 1 is 11. S equals 11. So if I substitute that back in, this is where substitution to check would be harder. 11 minus 3.8, yeah, it sounds like it's going to be close to 7.2, so we'll just go ahead and assume that answer is correct. So we learned adding and subtracting, multiplying and dividing. So in a situation where you're multiplying, 3c equals 6. A lot of us can probably see the answers too, because 3 times 2 equals 6. But what was the strategy to get c alone? Well, what's the opposite of multiplication? The opposite of multiplication is division. So I would divide each side by 3. 3 divided by 3 is 1c. So I'm left with c equals 6 divided by 3. So c equals 2. If it's a decimal, it might be harder to see the answer. So the strategy is do the opposite to each side of the equation. 1.6 times c. The opposite of 1.6 times c is to divide both sides by 1.6. 1.6 over 1.6 is 1c. So I'm left with c equals 4 divided by 1.6. So I have to divide. I can't divide by a decimal, so I'm going to move the decimal point over and add a 0. So it's really 40 divided by 16. And 16 goes into 4 0 times, but it goes into 40. 5 times 16 would be too much. 4 times 16 would be too much. 3 times 16 would be too much, so twice. 2 times 16 is 32. 40 minus 32 is 8. So I'm dealing with a decimal. Bring down to 0. 16 goes into 80. 5 times 16 is 50 plus 30 is 80. 5 even times. So c equals 2.5. So the opposite of multiplying is to divide, and I divided both sides by 1.6. One last strategy we learned was what to do when an equation has division in it. It's w divided by 2 equals 10. So a lot of us could probably see what divided by 2 equals 10 as 20. W equals 20. But what was the strategy to get w alone? Well, the opposite of dividing by 2 is multiplying by 2. So I would multiply each side by 2, because 2 times w over 2 becomes 2w over 2, and 10 times 2 is 20. Oops, 20. But 2 over 2 is 1w. So that's how I cancel out the dividing by 2. So I'm left with 1W equals 20. Well, we can't see the answer to this next equation because it's W divided by 3.9. So I'm going to do the opposite of dividing by 3.9, and that's multiply by 3.9, but I have to do it to both sides. This might be better written as a multiplication symbol with all the decimals. 3.9 times W over 3.9, these are going to cancel out, so I'm left with just W. And on the other side, it's 1.2 times 3.9. So I'm going to take out the decimals and just multiply 39 times 12. And there's going to be two places. There's one place here and one place here. To add the decimal back in, I'm going to move it over twice. 2 times 9 is 18. Carry the 1. 2 times 3 is 6. Plus 1 is 7. Add a placeholder. 1 times 9 is 9. And 1 times 3 is 3. Now I'm finding the sum. 8 plus 0 is 8. 9 plus 7 is 16. Carry the 1. 1 plus 3 is 4. So W is not 468 because 1.2 times 3.9 could not be 468. But if I move the decimal back in those two places I was talking about before, 4.68 sounds like a better answer. W equals 4.68. You try. Click pause. Copy these two problems in your notebook and solve them. When you're ready, when you're done, click play and I'll go over them for you. So click pause and try these two problems out. N minus 1.35 equals 19.9. The opposite of minus 1.35 is plus 1.35. So I would add 1.35 to both sides. Minus 1.35 and plus 1.35 cancels out. So I'm left with N equals 19.9 plus 1.35. I'm going to add up 0 for a placeholder. So they both have the same number of decimal places in them. 5 plus 0 is 5. 9 plus 3 is 12. Carry the 1. 10, 11. Carry the 1. 1 plus 1 is 2. Bring down the decimals straight down. N equals 21.25. Check your answer. See how you did. If you didn't get it right, try to figure out what you did wrong. Maybe it was adding the decimals, but were you trying to add 1.35 to both sides? If you were, that's a good step. The next problem is multiplication. 4.5z equals 72. The opposite of times z, 4.5 times z, would be to divide both sides by 4.5. 4.5 over 4.5 cancels out, so I'm left with 1z equals 72 divided by 4.5. So I have to divide 72 by 4.5. So I'm going to move the decimal in 4.5 over one place, which is going to mean I need to add a decimal place to 72. So it's going to be 45 divided into 720. 45 goes into 72 one time. 72 I have to borrow from there, make that a 6. 12 minus 5 is 7. 6 minus 4 is 2. Bring down the 0. 45 goes into 270. 4 times 5 times would be 225. 6 times would be 270. So it's an even number. 6 times 45 is 270. So z equals 16. How'd you do? Again, if you were trying to divide both sides by 4.5, that's a good step. If your mistake was in the division, then you need to practice and work on long division.